What's good, Logan? We got a test tomorrow, so I wanted to go over this review since I can't be there in person. I kind of wanted to just get down some how you would do the problems, or actually how I would do the problems. So I'll break this down into a couple of small videos so that you can, do the problems on your own and then see how they work out. All right, let's take a look at question number one. Question number one says, name the circle. The name of the circle is based on the center, so I would say the name of this circle is circle A because the center is A. So we're going to call this guy here circle A. So for this one, I'm going to say circle A. If you wanted to, you could also just write the circle and then put the dot and then call it like that. That totally works. Number two, name a radius. So the radius goes from the center to the outside, so you could call it AB. You could also use the one from A to D. Those would be the two radiuses I could use. So we'll say AB. That would be one of them. The second one would be AD. So those would be my two radii. Next, I'm going to name two chords. A chord is a segment that starts and stops on the circle. So this would be a chord because it starts on the circle at D, it ends at B. There is a second chord that starts at H and ends at C. So I'm going to be using those two guys right there. So our first one is going to be sorry, my mistake, DB. So we'll say D B is one of our chords, and the second chord is HC. Moving on, name a secant. A secant is a line that crosses the circle at 2 points. So this right here, that could be called a secant. Or if you wanted to, you would use this one right here. I'm going to use the HC because it's a complete line. It doesn't matter. Either one would have worked. So we'll say HC. But notice when I name the secant, I'm going to use the line symbol on top, not the segment symbol. Finally, name a tangent. A tangent is a line that intersects the circle at exactly 1 point, not more than 1 point, but just one. So GE intersects the circle at point F and only at point F. So we're going to say that the tangent is GE. I am going to use the line symbol to be as specific as possible. All right, let's keep moving on. Let's do two more problems. Let's do number 6. Let's find the radius of this circle down here. Noticing that AB is tangent, so AB is tangent right there, that means we have a right angle. And if we have a right angle, that makes this triangle a right triangle. So we're going to use Pythagorean's theorem here. First, we're going to say that the hypotenuse is r plus 9. So that side right there is r plus 9. So we're going to go the hypotenuse, the largest of the three sides, is squared, is going to equal, and Pythagoras said if you take the two smaller sides and square them, that would be the r, the smaller side, and the 15, the other smaller side. If you multiply them by themselves and you square them, you get the larger side being squared. Now we have to remember that r plus 9 squared just means r plus 9 times r plus 9. And then we'll go ahead and FOIL that. R times r is r squared. R times 9 is 9r. 9 times r is 9r. And 9 times 9, that's just 81. So this gives us r squared plus 18r plus 81 is equal, and on the right side of the equation, we get r squared plus 225. Noticing that we have r squares on both sides of the equation, we just cancel them out, subtract them from each other, and now we solve this problem like a linear equation. So we take away the 81 from both sides. This gives us r squared, this gives us 18r is equal to 225, take away 81, 125 plus an additional 19. So I'm thinking 144. So we get 144. We're going to go ahead and divide both sides by 18. And we get r is equal. This is a tricky one. It actually might go into it evenly, but I'm not exactly sure. So what I'm going to do is I'm going to go 144 is 12 times 12, and 12 is 3 times 4, and 12 is 6 times 2. Sorry, doing some goofy math over here. Divide by 18. Well, 18 is 6 and 3. Okay, so r is just 8. All right, now if you had a calculator, you can use a calculator. I'm just lazy and I didn't want to get my calculator out. All right, moving on to question number 7. We have two lines that are tangent to the circle. and they're tangent from the same exact point, that means those two segments must be equal to each other. So we're going to say 3x minus 4 is equal to 2x plus 1. And then we solve this equation by taking away the 2x from both sides and adding the 4 to both sides. So we add all the x's to one side, we add all the non-x's to the other, and we find out that x is 5. All right, hopefully these made sense, and then you're getting them right. I'll see you guys on the next one.